watch. So the first thing here it said count the total number of valence electrons. So we have hydrogen, we have oxygen and hydrogen atoms. So for oxygen atoms, how many valence electron do an oxygen atom have? Of course, we know that oxygen is element number 8 in the periodic table. And the electronic configuration of oxygen is going to be 2, 6. So it means oxygen has 6 valence electrons. So there are 6 electrons here for oxygen. There are 2 hydrogen atoms, so one hydrogen, the second hydrogen. Of course, each one of them will have only one valence electron. So one valence electron for the other hydrogen atom. So if we add them together, we're going to have total number of 8 valence electrons for water. So let's proceed from there. So the next is to count the number of electrons used in the bonds and determine how many remain. So I think I jumped step 2. So step 2, draw the skeletal structure with single bonds. So of course we know that oxygen will be in the central position. So we're going to draw O, and then hydrogen, they will bond around that O. So we did that already. So the next is to count the number of electrons used in the bonds and determine how many remains. So let me do that again, the one we did in the previous point. So how many electrons do we use in the bond here? So we use, remember, a single bond. We have 2 single bonds here. This is one single bond, and there is another single bond. And I told you that a single bond uses 2 electrons. So it means we have 2 single bonds here. So there are 4 electrons used. 4 electrons are used. So, and then remember, the total number of electrons that are used, that needed for this bond are 8. So it means 4 are used out of 8 electrons. So we have 4 electrons left. So that's what we said here. Count the number of electrons used in the bonds and determine how many remain. So there are 4 electrons remain. Now place electrons on terminal atoms to fill their octet or duet for hydrogen. Let me do this again. Electrons on terminal atoms to fill their octet. Octet means 8 and duet means 2 for hydrogen. Now, hydrogen atom will only have 2 electrons around it, maximum of 2 electrons around it. And if you count this bond that linked hydrogen to oxygen, there are already 2 electrons. Remember we said 2 electrons are used to make a single bond. So there are 2 electrons used here already. So it means we don't need to place more electron on this hydrogen since it has only 2 electrons needed. And the same thing, this hydrogen as well. So we are not adding any electron on hydrogen atoms, on the terminal atoms. And in our case here, the terminal atoms is hydrogen. So place the remaining electrons on central atoms to fill its octet. So let's do that again. Let's draw the bond again, or the structure again. So since we are not placing any electron on hydrogen, we still have 4 electrons left. And then we said place them on the central atom to fill the octet. And of course, the octet of oxygen is not fully filled yet. Oxygen is supposed to have 8 electrons around it, but it's having only 4 electrons. That is 1, 2 electrons for this bond, 1, 2 electrons for this bond. So the remaining 4 electrons, we place it 1, 2, 3, 4. So if you count the total number of electrons around each atom now, it should be either octet or duet. Octet for oxygen, 1, 2, 3, 4, 5, 6, 7, 8. And then for hydrogen, 1, 2. For this hydrogen, 1, 2. Remember 2. I'm counting 1, 2 because of this single bond. So we are done. Check that each atom has enough electrons around it. That is what I just did now. They have enough Each atom has enough electrons around it already. So we did that. I don't want to rewrite this again. Let me just copy this because we're going to need it in the next slide. So the next slide, what is there? Move electrons from terminal atoms to form double bonds so that all atoms have weight. So we don't need this. That's why I drew it out. So we don't need double bond in this case, and because everything is correct already for water. So if I go back, this is the Lewis structure for water. Draw the Lewis structure for water. This, and then you need to show the lone pair of electrons. So that's Lewis structure for water.